This is number 20 from the first semester final exam. In fact, this is 20A. 20A says radical x plus 7 minus 1 equals x. It wants us to solve for all values of x in simplest form. That means we're going to try to isolate things and then simplify it. We don't want to approximate using the calculator. So I'm going to write it out here so we can look at it together. We have the square root of x plus 7 minus 1. This minus 1 is on the outside of the radical, is equal to x. Just like we did on a previous problem, we want to isolate the part we want to eventually get rid of. We want to eventually get rid of this radical, so we need to isolate it first. What do we need to get rid of so we can isolate this radical? Well, we have to get rid of this minus 1. To do that, we add 1 to both sides. So we'll add 1 to both sides just like this. I bring down this radical x plus 7 is equal to x plus 1. So far, so good. Now I've isolated this radical x plus 7, which means that now I can do something to it. How will I undo a square root of x plus 7? Well, I can undo a square root by squaring it. And whatever I do to the left side, I have to do that same thing to the right side also. So I'm squaring both sides of this equation. The square root of x plus 7 squared is just x plus 7. So we have x plus 7 is equal to, over here we have to multiply it out. So this is x plus 1 times x plus 1. Let's go ahead and use the distributive property to see what we get. I'm just going to bring down this x plus 7 equals x times x is x squared. X times 1 will be 1x, and then 1 times x will be another 1x. Altogether that gives us 2x, right? If you don't see this, make sure you do it on your own. And then 1 times 1 is 1. So far, so good. In order to simplify this, we have to get it into a quadratic equation that's equal to 0. So I'm going to subtract x from both sides to help us get it closer to being equal to 0. So this is 7 is equal to x squared plus x plus 1, right? And now we have to get this equal to 0 still, so I have to subtract 7 from both sides. We're subtracting 7 from both sides here, and we get 0 is equal to x squared plus x. 1 minus 7 is negative 6. So we have x squared plus x minus 6 is equal to 0. If you don't like the 0 over there, you can just bring it over here like this. And I think that this can be factored. So let's factor this a little bit more. I'm going to break this into a product of two binomials. We have an x and an x. Do you see this subtraction sign? This subtraction sign is saying that these two signs have to be different. So I put a plus and a minus. What are two numbers that will multiply together to be a 6 but have a difference of only 1? Well, I think a good choice for that would be a positive 3 and a negative 2. I chose the positive 3 since I want to have a positive value in the middle. This is showing us that two possible answers. It could be, see, if x plus 3 is equal to 0, that means one possibility is that x equals negative 3. And if x minus 2 is equal to 0, then one possibility is that x equals 2. Now, for problems like this, we do have to go back and check. I'm going to write down the original problem so that we can check it. The original problem said that the square root of x plus 7 minus 1 is equal to x. Let's check this negative 3. So that'll be the square root of negative 3 plus 7 minus 1 is hopefully equal to negative 3. Negative 3 plus 7 is what? Well, that'll be a 4. So that's a square root of 4 minus 1 is hopefully equal to negative 3. The square root of 4 is 2, and 2 minus 1 is that equal to negative 3? 2 minus 1 is 1, and then 1 is, well, 1 is not. 1 is not equal to negative 3. That's showing me that this x equals negative 3 doesn't work. Let's try this x equals 2 instead. So we're checking x equals 2. So again, we have 2, and then plus 7, minus, bring it over here. Yeah, 2 plus 7 minus 1 is hopefully equal to 2. Here I have just replaced the equation. Everywhere there is an x, I put in our possible solution. Let's check it. 2 plus 7 is 9, so this is the square root of 9. Minus 1 is hopefully equal to 2. The square root of 9 is 3, so this is 3. Minus 1 is hopefully equal to 2. 3 minus 1 is 2 is equal to 2. That one does check, and so we have found a solution in x equals 2. That is the best and most simplified solution for this problem.